All right, let's run through this homework if you don't mind.
Hey, you didn't check Russ.
I got you. I walked right by you. Look good.
You get me?
Gotcha.
You get me?
Gotcha.
You get me?
Gotcha. All right. I know we didn't have to do the first couple. Of course, up here, things to note that we do have exponent rules. But I know we didn't have to do 1 through 6, but let's just talk through them, see if we can figure this out. So we started talking about scientific notation the other day. And scientific notation is a way for you to take a larger number and make it become a more manageable thing. And you usually with scientific notation, the accepted way to have it is you have a number, then a decimal, then up to 3 decimal places later, then times 10 to however many moments. So if we were talking about the speed of light being 186,000 miles per second, which is pretty fast, where would the decimal go on this problem? Where should it go if we wanted to put it in scientific notation? Is it between the 1 and the 8 and the 6 and the 0, or any of the zeros? Yeah.
1 and the 8.
1 and the 8. So I'm going to write 1.86, and I could put the 0, but usually it's no more than 3 decimal places behind it, usually I'm saying. And then I'm going to have times 10, and this is what we have to figure out. Okay, if I move the decimal here, the decimal technically was sitting right there originally. So you just count it. You're okay, 1, 2, 3, 4, 5. So 1.86 times 10 to the 5th power is scientific notation for writing what the speed of light would be. Okay? The angular velocity on a lighthouse, which means how fast does the light spin around for ships out at sea to be able to see it at night, is 0.036 radians per second. Okay? So it doesn't matter if you don't know what a radian is. Radian is about 22.5 degrees. But let's see. Scientific notation on this thing, I want to have, where's the decimal? The decimal is right here right now. But if I wanted to make it a scientific notation, where should I put the decimal? Yeah.
In between the 3 and the 6.
In between the 3 and the 6. So I should have 3.6 times 10. Notice I only have 3.6 here. I didn't have to carry it out any more decimals. Okay? And when you look at this, you have to realize the decimal's right here right now, and now I'm going to move it here, 2, 3. And being I moved in the opposite direction, so when you have a negative exponent for scientific notation, that means you're talking about a decimal, okay, a really small number. If you don't have a negative number, it means you're talking about a little bit larger number. And then a microchip holds 2 raised to the 64th bytes of data. 2 to the 64. I want to write that in scientific notation. Huh? What is the internet? Oh, the internet? Yeah. I got to think about that one. Well, 2 to the 64. Yeah, I'm not a big fan of what 2 to the 64 is indeed a big number. I'm not a big fan of trying to write that in scientific notation. I think leaving something like that, I'm skipping that one. I'm not going to have you do that because there's a skill that you won't learn until for 2 years now that deals with working with that. So I'm skipping this. I'm not going to worry about giving that kind of problem. Let's see. Write each number in decimal form. Okay, some students might look at that saying, well, duh, it's already in a decimal. Well, it just means get it out of scientific notation. So you have 1.773 times 10 to the 3rd. So this 10 to the 3rd right here, this means this decimal needs to become bigger, so it's moving this way. So we're talking about 1773. And then there is technically a decimal right here, but it's not really, you don't need to have it there. Credit card interest per day is 1.3 times 10 to the negative 2. The negative 2 means if I wanted to take it out of scientific, I'm going to move this way. And what do you think I should put in place if I need a placeholder? 0. So this will be 0.013. And old Peyton Manning's salary is 1.8 times 10 to the 7th. All right, let's figure it out. So I need to move the decimal how many places that way?
6, 7.
7. So I have 1, 2, 3, 4, 5, 6, 7. Is that all Peyton Manning's making? Only 18 million? Supposedly, according to this? I have no idea. Only.
No, baby.
Yeah, it's like pocket change. I mean, I got that in the trunk of my car.
Easy.
Yeah, right. Yeah, if you guys break into the trunk of my car, you're gonna find like soccer equipment for my daughter's
And a
soccer.
couple bodies. $18 million.
A couple Barbies?
Bodies.
Bodies? No, they're all at the lab.
I get it.
All right. Can I move down? So we're gonna work a little bit more scientific. Oh, I got it.
Oh,
Clear
I
all
did
that.
number 3.
Clear and ink. I guess I could have. All right. So let's see. So number 7, you had x squared y as a quantity, and you have that to the 3rd power. So I wrote out x squared y 3 different times, and I wrote it 3 different times because I had 3 times. So that became x squared y, x squared y, x squared y. And then if you add the exponents, it becomes x to the 6th, y to the 3rd. Yeah.
So you wouldn't like, you wouldn't like add, you wouldn't add any of these x, y.
Right. Well, this is the power that's or the property that's happening. We have power to a power, which means I would multiply here 3 times 2 to get 6, and then 3 times 1 to get 3. So I tried to write it a couple ways, where you had this 3 times where they're being multiplied, and then if you multiply like bases, you add the exponents, or you could realize it's power to a power. So on like number 8, I realized it was power to a power, so I realized 2 is raised to the 1st power, so if I do power to power, it becomes 2 to the 1st to the 4th, which is 2 to the 4th. And then, where did the c to the 12th come from? Yeah, President.
Times the 3rd exponent by 4 exponent.
Hey, where did 16 come from? Yeah.
You did 2 to the 4th power.
Yeah, 2 to the 4th, so 2, 4, 8, 16. Okay. Then problem number 9, I got rid of the negative exponent first, which made it 1 over v squared, and it still has a quantity going to be raised to the 3rd power. And then if I distribute in that 3, so power to power, so 1 to the 3rd, well that's just 1, and then v to the 2nd to the 3rd becomes v to the 6th, so 1 over v to the 6th is how you do number 9. Number 10, I took care of the negative exponent at the beginning, so that became 3 over b squared, and that quantity is still squared. And then I realized that the a squared b to the 4th as a quantity was raised to the 3rd power, so that became a to the 6th, b to the 12th. I simplified 3 squared over b to the 4th. Where did the b to the 4th come from? Where did this come from here? How did it go from this to this? Yeah, I stripped it. Good. So everything became power to power inside. And then once I got to that point, I realized 3 squared is 9. So I had 9a squared b to the 12th all over b to the 4th. And it looks like I had to do a tug of war with the b's in the top one. Could I have had 9a to the 6th, b to the 8th? Could I have put the whole thing over 1? Are you guys awake?
Yeah.
Yes, you're awake. Yes, I could have had it over 1. It's not necessary. So here's what the answer is. I transposed it over this way to start running out of space. Kind of clear?
Yes.
All right, number 11. It was 3 over 8 squared, so I realized that was 3 squared over 8 squared, and 3 squared is 9, and 8 squared is 64. So then I got an answer of 9 over 64. Number 12, I realized that it would have been 2 to the 3rd, and 2 to the 3rd simplifies to 8 because it's 2, 4, and 8. p to the third, and then over 125. Where did I get 125 from?
It's 5 to
5 to the third power, which is 5 times 5 times 5. Okay. 13. I got x to the 20, y to the 10, so I distributed the 5 to both the 20 and the 2, multiplied them. And then number 14, I distributed the negative 3 in first on mine, and that gave me x to the negative 12 and y to the negative 6. Negative exponents want to swap spots, so y to the negative 6 moves up, giving you y to the 6, and x to the negative 12 moves down, giving you x to the 12 on bottom. Let's see, number 15, I took care of the negative exponent first. I moved it down, so this moved to here. Okay, technically, I guess there was a 1 right there still. I distributed that in, so I got 1 to the third, which is just 1, and then x to the third, because 1 times 3, and then x to the 5th, or 15th, because it was 5 times 3. Number 16, all I did here is I distributed this 5 here and here. So I got 2x to the 5th, y to the 5th. The 2 wasn't raised to the 5th. And then here I distributed this here, here, and here. So I got 3 squared, which is 9, x squared, because that was to the first, and then x to the 8th, or y to the 8th. And then I multiplied the numbers together, 2 and 9, to get 18. Counted up, so I have those, so that gives me 7. Counted those, so that gave me 13. Number 17, I just distributed the negative 3 in. So if it came here, that became negative 12. That became negative 15. That became negative 21. And that became positive 6. This is the only thing that's okay where it's sitting. Everything else is going to flip-flop. So x to the 21 moves up, x to the 12 moves down, y to the 15 moves down. Combine like terms in tug-of-war. Tug-of-war with the x's, the top wins. Top x wins by 9. And then the bottom wasn't a tug-of-war, it was just a combination. 18, I distributed the 7 in on the top and the negative 3 on bottom. So I had x to the negative 14, y to the 21st, so the x to the negative 14 is going to have to move down. On bottom, I would have gotten x to the negative 9, which is now going to move up, and y to the negative 12, which is also going to move up. So the next step shows that I moved them all up. And then, let's see, I'm going to do a tug-of-war with the x's. Didn't look like a reducer right. Tug-of-war with the x's, that should have been x to the 5th. Sorry about that. I think the rest of it's right. Okay, 19. I would bet you're definitely going to see something like number 19 on the test. It looks way too complex. You have x raised to the e power, y to the pi, x to the lowercase theta, x to the lowercase theta, y to the, I can't even read that, y to the k maybe, z to the n. The whole thing is grouped and raised to the 0 power. If that takes place, the answer just becomes 1. Yeah. I'll look it up for you. I'll look it up in a few minutes. Quiz. It's a quiz coming up next week.
Next Thursday?
What's next Thursday?
Because we don't have school on Friday.
We don't?
Yeah, we don't.
Bruh.
Thursday.
Oh, but I gotta be here. I'll call all you guys. Make sure you're awake.
Oh, no.
Hey, what's up?
Yeah, I was gonna just like turn all your devices off and lock the door on Thursday.
Alright, last one, number 20. Looks like I can combine the 8 and the 2 to get 16. The y's combined give me y to the 14th. The x to the negative 10 is going to move down, so now we're going to do a tug-of-war. And we get x to the 8 on bottom. So that, guys and girls, is basically how you probably should have gone through your assignment. Now let's take a look. When is our opportunity to show how good of a teacher I am? What's today?
17th.
Okay. Tuesday next week is our quiz number, our next quiz. Huh, okay. Let's take a look. All right, where are we at? So, I'm going off the cuff a little bit on this one, meaning I'm not going with an exact lesson, but I just want to see how we do. If you have your workbooks with you, turn it to page 33, which is worksheet 16, if you don't mind. Turn to worksheet 16. Okay? So I'm pretty sure 1, 2, 3, and 4 you're going to be able to do without any problem. Okay? That's just converting it into scientific notation. So if you remember scientific notation, you have a single digit, then a decimal, and then up to how many more numbers could you have? 3. And then times 10 to the however many you move to the right for positive, and however many you move to the left for negative. And then number 5 through 8, I'm pretty sure you can do. It's just converting that back into a decimal form. But then I want to look at 9 through 16. Okay? 9 through 16. Let's make this all the way. Okay, clear ink. All right, so if I had 5 times 10 to the third power, and I wanted to multiply this times 7 times 10 to the fifth power. Okay, so let's figure out how to do it. So scientific notation, our grand goal is to have some answer look like this. Okay? So that's what our grand goal is going to be. We still okay? So let's figure this out. Let's do it the way that we might know how to approach this problem. 5 times 7. Okay. I'm okay with that. You okay with that? Like bases that I'm multiplying, what do I do with the exponents? Add them. You okay with that? Now, this looks a lot like scientific notation. But what's the problem? There's not a decimal there that we're seeing right now. Actually, our decimal is sitting right here right now. Where do I need to move the decimal? To the left. I need to move the decimal here. Okay? So I'm going to get 3.5. Do I need anything here or here? No. Times 10. Okay. 35. So if I took the number 35 and I wanted to convert it into scientific notation, this would become 3.5 times 10 to the first power. So that means that this has to increase. So this is going to be times 10 to the 9th. So our answer is 3.5 times 10 to the 9th power. Can I try one more of those? May I clear this one? I just made it up off the cuff. Can I clear it? So let's try another one. See how we did this. Okay? So what do you feel that multiplication-wise we should do right now? Yeah, 7 times 6.1. Definitely. Okay? So I'm going to do this times this. So how is this going to look down here? How will this look down here? 4.27. So we're going to have to move the decimal, okay? So we know this is going to take place. So I'm going to put that we are going to move the decimal left 1 spot. Okay? All right, so we're not done yet. So let's do the math that's going to take place here to fill in the rest of this as sloppy scientific notation times 10 to the 10th. So what is this going to be? Yeah, 11. Good. So that means that this decimal is going to move. So up here, this means technically it moves 10 this way. Now with it like this means it has to move 1 more spot. So now it's going to move 11 spots. I'm almost clear on this. Let me try one more. Is that okay? Can I clear this one? Okay. So what technically should we multiply together? 9 and 8.93. Does someone have a calculator out real quick? I can't do it in my head. I apologize. What are those? What is that multiplied together? Please. Yeah.
80.37.
80.37. Okay. So I think we can finish the rest of the problem. Times 10 to the what? 10 to the 10. Okay, so this is kind of the sloppy way. What is this technically going to look like down here? 8.037. Now I said you could usually go up to how many decimal places? 3. Are we still falling into that?
Yes.
If we don't fall into that, don't go and take this so far out. Okay? Take it to 3. So you might have to truncate it. You might have to chop it off. You might have to round it. Yeah.
Wait, so is that a comma or a dot?
That's a decimal. Dot. Sorry. Okay? Times 10 to the what? 11. So remember, this is moving it 10 places this way. If I move it this way, that's going to be 1 more direction. I think I'm okay with this. Are we okay? Yeah.
So on the page there are some problems like number 6 times 10 to the 6 over 2 times.
Yeah, I'm going to get there right now.
Okay.
Is that cool?
Yeah.
Okay. Do you all feel comfortable with this so far? Tristan, you need to go to the nurse because you're not going to sit here and sleep. Go to the nurse. Seriously, you're sleeping. Go to the nurse. All right, let's figure this one out. Let's say we had let's go. Okay. I think I could do this. So let's treat 3 over 6 just as its own fraction. Does it reduce? What does it reduce to? Half. Is that okay so far? I think we can do tug of war right now. You with me still? Who's going to win, top or bottom? Bottom by how many? How much?
6.
By 6. Okay. 1 over 2 times 10 to the 6th. That's it?
we need to make it 217.
We would add the zeros.
Wait, what? I'm doing what? Yeah. What do you think?
Like put it in a decimal.
Put it in a decimal? You want it as a decimal? I don't know. I think we could be done with it. Hey, where did 10 to the 8th go?
It lost
Tug of war.
Yeah, I lost the tug of war. So how many is left if it lost? Zero. What is 10 to the 0 power? 1. What is 1 times 1? I think top is legit. Bottom, am I allowed to have 2 times 10 to the 6th? God bless you.
No.
I think we could. Huh. What the heck is even taking place with this kind of problem? How would I write 3 times 10 to the 8th not in scientific notation? If it was just 3 times 10, what would we have? 30. If I had 3 times 10 to the 2nd, which is 3 times 100, we would have 300. So really what's happening here is I have 1, 2, 3, 4, 5, 6, 7, 8. And on bottom I have how many zeros? 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Woo! Okay. That 0 cancels that. That cancels that. That cancels that. Still with me? That cancels that. Still with me? That cancels that. Still with me? Decimals right here. 1, 2, 3, 4, 5, and 6. Done. That's what happened with that problem. Huh. Wow. I think you have enough to start this. Worksheet 16. I think you have enough. A lot of it's review. Let's just see how you do with it. Yeah.
Maybe work with a partner.
Absolutely. Yeah. Work with each other. Yeah.
So you do the top doesn't go into the numerator, doesn't go into the denominator either.
If it doesn't go in there evenly,
Because on the homework it's 2 to 5.
ooh. Try that. See, do your best effort on it, and we'll see what happens with it tomorrow. If it doesn't go into it, Ray, I bet you got to keep the 2 and the 5 as is somehow. But I bet you could do tug of wars with the 10s. I bet you. And if you don't see that one real well, you might want to work it out this way. But worksheet 16 is for you guys today.